Okay. Welcome to the stream. Today, I guess I'll start with an introduction. Hi, I'm Kent. I'm doing some live streaming on Watching Me Code for, I'm solving the Advent of Code problems. Advent of Code is a series of 25 daily puzzles around Christmas every year, ending on Christmas Day. And they tell a cute story. It's adventofcode.com, and today is day 4. And I'm going to take a look at the puzzle for the first time live on the stream and try to solve it. I normally use Go, but if the problem seems particularly intractable in Go, then I might try Python instead. So that's the plan, and if I have time, if it goes quickly, then I might even solve it in both languages. Let's get started. I'll show you what I'm doing. So this is my desktop. I have an editor over here. I have the Advent of Code problem. This is the one I solved yesterday. So today we now have day 4 available. The problem always exposes some picture as you go. We're gonna open this one up. And let's see what it says. Our fiction here is that we're preparing for a trip, and so now we're arriving at the airport. So the problem says you arrive at the airport only to realize that you grabbed your North Pole credentials instead of your passport. While these documents are extremely similar, North Pole credentials aren't issued by a country and therefore aren't actually valid documentation. Seems like you're not the only one having problems, though. A very long line is formed up for the automatic passport scanners, and the delay could upset your travel itinerary.
I have to turn my volume up to 100% to hear you.
Thank you for that. I'm getting some nice feedback here on what I have to do, so let me try turning my volume up and get a little more.
You want to go test in there?
A second. Oh, not that switch. This switch. That turns me down. Okay, that's my gain there. Oh, I guess I can raise this gain.
Yeah.
So that was my mic gain, pushes me close, but I can up this a little bit. How's this? Okay, not yet. Let me see. Is this better? Okay. I can also move the mic a little closer. Try that. See if that. Oops, it's sagging a little bit. Sorry. Okay, how's that? Is that better? You can hear me now?
It's much better.
Okay, thank you. It's nice having an in-house viewer. Okay, we are dealing with an automatic passport scanner. The automatic passport scanner is slow because they're having trouble detecting which passports have all required fields. The expected fields are as follows: birth year, issue year, expiration year, height, hair color, eye color, passport ID, country ID. And all of these have 3-letter codes. Passport data is validated in batch files, which is your puzzle input. Each passport is represented as a sequence of key value pairs separated by spaces or new lines. Passports are separated by blank lines. So step 1, this is a parser problem. We have to collect these things and store them. Here's an example batch file containing 4 passports. And so we have a series of lines that may want to be concatenated together, but they're separated by a blank line. So here's some examples. The first passport is valid. All 8 fields are present. The second passport is invalid. It is missing the height field. Third passport is interesting. The only missing field is CID. So it looks like data from North Pole credentials, not a passport at all. Surely nobody would mind if you made the system temporarily ignore missing CID fields. Treat this passport as valid. Okay, interesting. So they gave us a list of required fields and then told us not, if CID is the missing field, then we don't have to worry about that. So we just not, according to the above rules, your improved system would report 2 valid passports. Count the number of valid passports, those that have all the required fields. Treat CID as optional. In your batch file, how many passports are valid? So this is basically going to be writing a quick parser. So I am going to do it in Go. Even though it's probably trivial to do it in Python, I'm going to do it in Go and make it a little more interesting from that sense. So the first thing I got to do is actually set up my editor so that I can program this. Now, one of the things I discovered is that the VS Code editor requires you to uses GoPlease as a library or as a plugin of something, a service for doing IntelliCode and things like that. And you have to open it within the folder that contains your Go mod file. In this case, I'm going to be creating a new directory that has a new Go mod file. So therefore, I'm going to import. I'm going to start a new editor. So close this one. Close this one, and let's open an editor on my new file. So we're gonna go up a level, and then I'm gonna copy my template to day 4. So copy -r underscore template. The -r is recursive because I want all the files that are in the template directory into the day 4 folder. And then I'm gonna VC day 04. So it's going to open a new editor on that directory, and notice I've got a bunch of files here. So I have my input file and my sample file. So what I'm going to do is I'm going to copy this data here into the sample folder. And that's my sample data. And then I'm going to go to my puzzle input, and that has a lot more data, and I'm going to copy that and input that text, and there's 1,000 lines there, so a couple hundred items, and so that's my input file. And my Go file is currently set up so that what it does is reads the input file, and then does a read all of the entire contents of the input file into just one big buffer, and then splits that buffer based on lines. Now in this case we may want to change the way we do the split, so I'm gonna think about this for a minute. Let's take a look at the input again. The input is blocks of lines separated by a blank line. So instead of splitting on one new line, what if we split on 2 new lines? Would that work? Now, if we use strings, we're going to have to split on a specific string. And the only danger of splitting on 2 new lines is if the blank line actually had some spaces in it. Now, if I highlight this, it doesn't look like there are any actual spaces in the file. So we could probably just split on 2 new lines and be okay. If we wanted to be more robust about it, we could use regex.split and split on a pattern of multiple new lines that might contain white space in the middle. Just for fun, I'm going to do that. So let's do this. Let's do, we're going to create a split pat, and that is going to be, split pat is a regular expression. So we're going to do regex dot compile. Actually, I'm going to do must compile because it's easier. In this case, if it fails, I just want to know immediately it's a programming error. It's not something we have to worry about at runtime. So I can just do a must compile, and this will abort if I make a bad pattern. And the pattern we're going to be looking for is pretty simple. It's just new line and some number of spaces. And you know what? Instead of... So let's do... I'm going to look up my regexp syntax. And I just wanted to remember what the backslash code for space is. Or just name character class. So Perl character classes, I can use \s, meaning white space. Or I can do an ASCII character class, which I actually prefer just because I think it's clearer. Because like I just said, I couldn't remember what space is. So I'm just going to do n on a white space. Oh, no, this doesn't work. I can't do this. Okay, never mind. The reason I can't do this is white colon space also includes new lines. So what I'm looking for is I want two new lines with only spaces or tabs in between. So instead, I'm just going to make a pattern containing spaces and tabs. So square bracket means start a group. Space is one, and \t is the other for tab. So spaces or tabs in between, and then we want to have 0 or more of those are allowed on that middle line, and then another new line. So \n. So that's the thing we're going to look for, and then we're going to split the string we read in on that. So that's what this pattern is searching for. And then now we're going to do, instead of string.split, we can do splitpat.split. And now we just pass it in the buffer that we have, and we don't have to have a second argument here. So that's going to split that string on empty lines. So now what I'm going to get here is each string in my array of strings generated by splitpat is going to be a single passport record. So the first file we have, I should see 4 records. So in fact, I'm going to do this. We're going to print the first record, and then we're also going to print the length of lines. And this little program, I'm just going to run this right now to make sure that for input sample.txt that we have 4 records. And if that works, then the thing I just did is working right. So cd day 04, and then we're going to go run main.go. And splitpat.split needs another argument. I guess I should have seen that when I looked at my editor. It takes a number, which is the number of splits to allow. So in this case, we just want -1, meaning do as many as there are. All right, now there are no curly wiggly lines under here, so this should actually compile and run. So that's the first thing, and notice there's a little 4 at the end. I didn't print it on a separate line, but that gave me my first thing on 2 lines, and so this looks like our concept of how we split this up works. Great. So now I have a collection of strings, each of which contains these little records. And so what we're going to do is we're going to split those on white space. And then we're going to split, once we get them on white space, then we can split them on colon. So we could just do this with further calls to split and splitpat. Create new patterns and split it that way. The other way to do this is to write one regular expression that looks for these things, and then we tell the regular expression just generate all the matches within this string, and we will get a collection of pairs. That might be a fun way to do this. All right, let's try it. So I don't need this line anymore, but I'm just going to comment it out. Instead, what I'm going to do is going to write a new function. And that function is going to be called day 01. No, sorry, it's day 04A, because this is always the first. One of the things about this is there's always two sections. You do the first one, you get that right, then you do the second section. Only once you get the first one right. So, and it's going to take an array of strings as its input. Whoops, I guess we give it a name. So we'll call it lines as an array of string. And for now, we're not going to have a return value. We might come up with one later. Let's see. Okay, we have to count. So I'm going to actually return an integer for now. Now, one of the things I'm doing here is I'm not worrying about error returns. If I were writing real production Go code, I would be doing error returns as, you know, if you have error reading the data, you want to not just crash, you want to actually return an error. Or, you know, you could try to throw, but I don't like to do that. So, but in this case, I don't mind if we're just going to call log.fatal if we have a problem. So we don't have to worry about that. So, here we go. We're going to take our line. We have an array of lines. And then we're just going to walk the array and call a validate function. And then I'm going to write the validate function. So we're going to do for line colon equals. Sorry, we're iterating an array. And so the first member of the iteration is the index. And we don't care about the index right now. And then the second is the value that the iteration gets. So, range lines. And so I just got to notice that there's a new version of Go Please available. No, I'm not going to get it for right now. We're just going to ignore that message for the time being, and we can come back later and maybe update later. Hey, somebody just put a note in. Hi, P Hacky, PH. Anyway, the thing about these puzzles is that they tend to start easier in the beginning of the month, and the first half of every puzzle is always easier than the second half. The way these things always work is they give you the same data, but then they change the rules in some way, and you have to do a little more work on it. So the typically you'll see, problem number one, you interpret the rules and it's an n squared calculation, and then the second time you do it, it's an n, order n cubed kind of thing, and maybe you don't have enough processing power to do that in a reasonable amount of time with the data you have, so you have to think about your algorithm. Or sometimes it's just adds an extra constraint, or so it can get interesting. So anyway, we're on to day 4. So far this year, the puzzles have been pretty easy. I've been able to solve all of them with reasonably nice code in less than an hour. The first one, I can even show you real quick. They're on my GitHub. So if you look at Kent Quirk, github.com/KentQuirk/AOC2020, I'm keeping all of the puzzles there. Obviously today's not in there yet because I just started it. But day 1's puzzle was a puzzle where you had to find a set of numbers that added up to 2020. And the first version of the puzzle was to find 2 numbers that added up to 2020. And then the second time, you had to go through and find 3 numbers that added to 2020. So that got it kind of interesting. Thank you, you are super duper. Appreciate the link. So this puzzle wasn't that hard. It's pretty easy to do it as a triply nested loop. I chose to do it because I felt like it was going to get more complicated. Like the second version of the puzzle, you needed a triply nested loop, which is an order n cubed problem. So if you switch it to an order n squared problem, sorry, I did the thing using a set that I then could intersect two sets, and which is an order n problem, and so I turned it from an order n squared problem for the first one to an order n problem, and then in the second iteration, it turned it from an order n cubed problem to an order n squared problem, both of which are more tractable. In these cases, both of these problems were perfectly fine to just run. They run in milliseconds regardless of what you do. But it's an interesting exercise. So this is the first few days are just going to warm you up. It's going to get more interesting as we go. So so I thought the first one was I made it more complicated than it needed to be, but it was interesting. Day 2 was also pretty easy. Day 2 was parsing these lists and then evaluating the passwords. The evaluation function was really easy to write for both part 1 and part 2. It was just different. And I did it with regular expressions, but you can do it in a variety of interesting ways. And again, both of those, all three problems so far I've solved in both Go and Python. But the Python version of the code is a tiny little program. It's just a few. I guess I can make that bigger so you can read it more easily. Whoop, that's smaller. Sorry. But the Python version of this code is like ridiculously simple. And then day 3 was a problem where you had to evaluate this. Again, it's a simple parser to just read these lines of data, and then once you get the piece of data, then you have to evaluate it, and it was simply a matter. This one was mainly a test of whether you understood how the modulo operator worked, and if you're doing something with modulus, and you're not making foolish mistakes, then it's going to be pretty easy to solve. So my evaluation so far is that this year has felt easier than previous years, but I also may not remember very well what some of the earliest ones were in other years. These things always kick your ass as you get closer to Christmas, so we'll see how that goes. But I'm going to go back to the puzzle now and talk about the code. So here I've just done an iteration on a range of lines. Please feel free to ask more questions. I'll try to notice them as they go. I'm iterating over the range of lines, and then I'm just going to simply call a validate function for each one. Now, the validation question is whether to create a data structure for this. The trivial validation would just be testing whether the keys for each passport match the list of valid keys. But the question is, should I build a data structure for a passport and then test whether, test for the presence of each of the keys? Certainly I can. So what I'm going to do, actually, each passport is nothing but a bucket of key value pairs. So I think it makes the most sense. I don't think we really need a. Actually, I am going to do a data structure, but what I'm going to do is, instead of a data structure, I'm just going to do a type alias. So we're going to create a type. We're going to call it passport, and it is going to be a map of string to. And I'm just going to go string right now. Oh, oops, sorry. No, second brace. String. So it's going to be just a map of string to string. Because I made it an uppercase type, then I need to put a comment in that says passport represents passport object as described in the problem. So And then what I'm going to do, because the reason I made a type is because it's useful to create functions on the type. So I'm going to create a validation function that can test the type. And so our first validation function we'll just call it func. And we're going to take a passport object. Sorry. And I don't need to make it, I'm not going to bother to make it this is essentially just evaluating an object, so I don't need to pass a pointer to it. I can just look at the map, read the contents of the map. I'm not modifying the map. So and we're going to call it validation A because it's part A. And it's going to take no arguments, but it's going to return a bool. Tell us whether this thing is valid or not. So when I have one of these passport maps, validation A is going to take the list of keys and check to see if all of the keys that are mentioned in a sublist exist. So there's going to be a const array of string. Actually, required keys. I'm going to put an A in for part A. And that is going to be an array of strings. Array of strings. And the strings are going to be the required keys, which are, here they are. Birth year. Issue year. Expiration year. Why don't I copy this? I'm going to copy these, and instead of doing this, I'm going to paste this in, and then we're going to use a cute trick of our editor. We can do column editing, and I can go quote, quote, comma, and then I'm going to do a comment. All right, so that's my required keys. And the validation is going to check to make sure that each key in the map is a key in my required keys list. Now, actually, one of the things they just said is that the country ID we're going to make optional. So, at the moment, I'm going to just comment that one out. It may change this strategy later, but for now, let's just do this. So there were 7 required keys, and that's the rule for the moment. I'm sure that in part 2, they're going to make the other one required, and we're going to do something with this, but for now, I can live with this. So, I made this an array of string, but the question is, testing membership in array of string, it might be easier, instead of making an array of string, if I made it a map, because testing membership in a map is very simple. So, let's take a look at that. Yeah, I think I will. So let's do this as instead as a map of string to now. So what I want to actually here is a set. If I were using Python, I could use a set directly. A set is just something that stores a single copy of each element in the set. And if you add the same element 5 times, you only end up with 1 in the set. And it's very easy to test for membership in the set. It's an order 1 operation to test for membership. And you can also do things like set. You can write algorithms to do set intersection and things like that very easily in Go. In Python, there's a whole set of set operations and intersection and union and all that are already in the language. When I solved day 1 or 2 here, I did the same thing I did in integer set, and I'll show you that. To solve for day, I think day 1, no, it wasn't. Yes, so here on day 1 we had an int set. So I created an int set, which is a map of int to an empty struct. Now, one of the nice things about Go is an empty struct takes no space at all. So when you when you want to make a set, you make a map of int to empty struct, and it's the same thing as if you had a set data type. In this case, on day 1, what I did is I made an add to put an item in the set. I made a contains function because it's easier to test for value, and I made an intersect function. And in this case, I can do actually all of those things here, and it might be useful to do that for a string set. So let's just do that. Let's just create a string set object. Then we can make required keys be a string set. And so we're going to go here. This is really probably more elaborate than I really need to do, but I'm going to just rename the symbol and set to, no, that was in a comment. Of course I can't rename it. Rename the symbol to string set. Change my comment, add, puts an item in the set. I think I'm going to change all of these elements to S instead of I because I like that better. Whoop. Yeah, I can just do it. It's faster. S. And then S. And then this, because now J doesn't really work very well, so I'm going to rename that too and make that T. In here, it's K is fine because it's a key. So for key in S, if T contains K, result that. So now I've got a nice little string set that I can use, and I can add all the keys and required keys to the string set. Maybe oh, these are not ints anymore. These are strings. So do shoot. All right, let's do this again. Okay, so I fixed my comments. It's a little better, and we can make this be, if we allow this to take any number of arguments, then it makes it a little easier to initialize. So, and then what we're going to do is, for a underscore comma a colon equals range of array, then s of a is this empty struct. So what I just did, by taking dot 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 string, that means there can be any number of arguments that are strings in this add call, and then we're going to add all of them to the set. This lets me create required keys as a string set. And you know what I'm going to do, just to make this a little more fun? This is going to return a string set, because then I can add the items on one line. This is what's known as, what's it called? Literate programming or something like that, where you can kind of write a line of things with a series of dots and make it work that way. It's not very Go-ish, so maybe I'm not going to do that. I'll just leave this alone for now. Sometimes it's nice to just think about, you can just initialize it, build it and initialize it in one line. In this case, it's maybe overkill. So, but this is no longer going to be a const, is it? I still need it as a const. That's why it would be good to do this as a string set, because then I can do it as a var anyway. Alright, so let's do this. Equals. Required keys k equals make string set dot IntelliSense doesn't like this. Oh, it's because it needs to be var. No. I'm just trying this. I'm going to comment this out for a minute. Save it. Oh, now I can't use colon, right? Because it's a var. Oh, because add is needing to be on a pointer to a string set. What I'm trying to do, the reason I'm struggling with this is I'm trying to create a string set. I'm trying to create this as a constant that I can use, or as a exterior variable that I can use in initializing, without having to initialize every call inside of validation. But I could instead, let's do it this way. Let's pass it in. Yeah, because we're going to probably end up modifying this anyway. So let me just make sure this works. So I'm going to take the var out. I'm going to do required keys, colon equals, make of string set, and then required keys a dot add of all of these things. And this is also in the wrong function. Sorry about that. I'm going to move it to day 4a. So I'm going to build it in day 4a and then pass it in is part of validate's parameters. So validate now gets a string set. And then this no longer needs to be capital required keys. It's just going to be... and now these are going to move in here. And we're going to take the comments off them and save that. Beautiful. Okay. I can live with that. So now I have required keys, which has a bunch of these required keys in it. And the validate function now takes required keys and returns a bool. So, and we call that on each passport. So what we're going to do is, I haven't written the validation function yet, but I can write the thing that's going to call it. So for each line, you know what? I don't like calling this lines. I'm now going to call it passports. And line is going to be passport. That makes me feel a little better about what it's actually doing. Just to get this error to go away, I'm going to call day 4a of passports. And then here, now that we have it, we can say passport.valid. Oh. Yeah. I'm going to call this PP here. So for each, so the passports is strings. I need to turn that into these maps. So I need to parse a map into a passport. So we need to write a parse function. So let's write that parse function now. So here's my passport object. I have a validation function, but before I have a validation, I have to parse it. I have to be able to build one. So func. Now parse can't operate on a passport object. Well, it could. You could construct a new empty passport object and then call parse on it with a string. Maybe we'll do it that way. So because we're going to be modifying the passport object, we need to pass it a pointer to a passport object. Even though it's a map, we need a pointer to it so that we can modify it. This is going to be parse, and it's going to take as a parameter s as a string. So it's going to take a string, and it's going to turn it into a passport object. So what that means is that we split up. Whoops. I forget which language I'm writing sometimes. So this in fact, I'm going to call it parse from. The input string is expected to contain 3-letter keys with arbitrary values separated by colon. That's this character, and each key value pair separated by white space. So what I'm going to try, and I think this will work, I'm going to try taking my white space, writing a regular expression that matches a key value pair, and then do a find all subgroups. So I'll show you how that's going to work. So KV pattern is a must compile regexp dot must compile of now here's the thing. So key is an alpha, A through Z, and it's exactly 3 characters. So I can put a character count in there and say this is what we're matching. We're matching 3 characters in the range A through Z, followed by a colon, followed by any number of characters. I don't need to do a group. I'm just going to go. Actually, what I'm going to do is I'm going to do an exclusive group. I want anything that is not white space. So, actually, now that I say that, non-white space has a group, and that group is called oh, funny, there was a group here, blank. I didn't even realize there was a group called blank. So maybe I'm going to change this to be, again, to be more clear, bracket, colon, blank, colon. But meanwhile, this pattern, how do you do not ASCII character classes? Actually, I can just do Word. I think we'll do... So in this, instead of this, we can do bracket, colon, lower, colon. And in this, we can do bracket, colon, word, colon, bracket. Now, all right. Some people are terrified of regular expressions. Some people hate regular expressions. I can kind of see that. It's an easy way to solve this problem for my brain, but maybe other people don't like that kind of solution. To read this, you say, look, okay, what are we compiling? There's a character class called lower, which is lowercase letters, and the curly brace 3 means there are exactly 3 of them. If you say, 3 comma 5, there could be 3 to 5 of them, but in this case we're just going to say there are exactly 3 of them. And then word is defined to be all of these letters from 09 A through Z and underscore. Let's just make sure that we actually don't have things that are outside the word set, like hyphens or see, like here's numbers in letters. See, here is a non-word character. So we should, since we have to worry about that, I'm going to go back. I'm going to change my mind. I'm going to get rid of this character class, and I'm going to use what's called an exclusive character class. And I'm going to say I want anything except a space. And the way you say that is you use the square brackets to mean a group of characters, and you use caret, meaning invert, as the first character. And then that means the rest of this character class is inverted. So actually the only thing we have to do is put a space in there. So anything that's not a space, and actually I'm going to add tab to it as well. So I'm going to do /t, and we have a tab. Sorry, so anything that's not a white space in a tab. And a new line. Let's make a new line in there too, because we know that new lines are going to be in there. And because new lines can be in there, then maybe ours can be in there too, because maybe we're on Windows and new lines are actually ours, include ours, so we don't want to even have that argument. Let's just have it there. So, basically non-white space characters. So, and then we need any number of those. No, not any number, one or more. So, sorry. One or more of those is a plus. So, we're going to find, so we have this pattern and it matches that sequence. And then we're going to pass that on the string. We're going to say find all of the matches in the sequence. And that's going to give us back an array. So here's what we do. We just now say from that string, we say kbpat dot. And so the find thing, so we need a find all. So it has to start with find all. And then we want string, so it's find all string. And we want all the submatches, so it's find all string submatch. Ah, yes, Coriolanus. Thank you for that reminder that \s works for non-white space. I tend not to use those things, but yeah, it's a good point. Non-white space that's exactly what I was looking for. So I don't know. I'm gonna leave it the way it is for now. But I appreciate the reminder. Thanks a lot. So find all string submatch is doing a it's going to take and return all the strings. Notice when we look at it, see, it takes a string and takes a number, so we're going to pass it s for our input string, and we're going to pass -1 because we want all the matches, and it returns an array of strings. So because each submatch could potentially have, oh wait, no, find all string, I don't need find all string submatch because I don't have submatches. So yeah, let's just do find all string, and that will return an array of string, which is all of the versions. The slice of successive matches of the expression is defined by the all description, and a return value of nil indicates no match. So we're going to say matches is find all string, and if, no, actually I can just iterate through the matches. Wait. Yay for regular expressions. So now what I've got is for each match, I'm going to have to submatch that. So if I wanted to be clever, I could include subgroups within this regular expression. And I can separate out the key and the value by wrapping these in regular expressions. And then if I do find all string submatch, I'm basically walking through the master array, and for each master array I have 2 elements. So just to show you how that's going to work, I am going to do that. So I'm going to wrap these guys in key, paren there, and then skip the colon because the colon isn't meaningful to us, and then all of the non-match characters here. Now matches is find all string submatch is what I want here. And now I can iterate over matches. So for underscore comma m semicolon equals range matches. So for each match, this is the outer array, I'm going to have M is now, I'm going to change it to M. That's a terrible name. I just like to indicate that it's plural, that there's a group here. So for each of those, I'm going to separate out the key and the value and store it in the passport. So I can say key is, now one of the things about find all string submatch is, say there are two submatches, you're actually going to get 3 elements in your array. The 0 element in the array is the entire match, and then the 1 element in the array is the first match, and the 2 element in the array is the second match, and so forth. So what I want is the key is m's of 1, not m's of 0, and the value is m's of 2. But I should have checked this for nullness. No, if m's exists, it has to match 2 elements, so I don't have to check those for nullness. And matches, if matches is nil, that for loop will do nothing, so I'm fine. Now I need to just say that p of key equals value. So now I'm constructing that map of my passport. Oh, geez. What have I done wrong? Or is this... cannot index be... Oh, right, because P now has to be converted to a map. No, star P. Sorry, it's not converted to a map. I just have to use its index. There we go. That's better. Okay, good. Because P is a pointer to a passport. So in order to index into the passport, I need to convert the pointer back to a passport. So star P of key is value. So now we're modifying the passport. So this is basically parsing a passport from a string, building in the passport. So there we go. Now we walk our range of things, and we're going to create passport. Passport gets is a new passport, and then since that, and that's now new gets you a pointer to a passport that's allocated. So we are now creating that passport, and we are going to do passport dot parse from pp, and that's creating a passport object. And then finally we're going to do passport dot validation a, which is going to take required keys as a parameter. I'm not doing anything with that value yet, so for now I'll just leave that and we'll come back to it. Here, validation A, how are we going to validate this thing? So we have a map of string to string. We are we're going to take and we essentially want to do an intersection of 2 maps. So I had an intersection function that I pulled in from Monday, or from the first day. But in this case, it's not a string set that I'm intersecting against. I can construct a string set from my passport, from the keys of the passport, and then call intersect on that. That was why I put it in the map in the first place. Or I could just iterate the map. So what I have to do is I have to look at the map, and I have to say what keys are in it, and how many of them are all the required keys there. So let's just do this. For each key colon equals range p. Yeah, p is the map. So we're gonna get our key. We don't have to worry about the values in this case. And we are going to if required keys contains key, we're going to increment a counter in required keys is initialized to 0, and required keys plus plus, and then at the end we can say return and required keys equals length of required keys. So if all of the required keys were present, then that count will be, this could be a problem if there are duplicate keys. So by checking it this way, as opposed to building a map and doing an intersection, I think even though it's probable that they don't have duplicate keys, I don't know, they might. I could just imagine him pulling off something like that. So let's not do duplicate keys. Just gonna put this here for now. 4 key in range. All right, so we're going to make a string set. For key in range of P, existing keys dot add of key. If we were going to do this, I might add the feature to the string set to take a passport and make a string set out of it, but it doesn't matter right now. This is fine. So now I have 2 string sets, one for existing keys and one for required keys. And so now what I can do is I can say intersection keys is the existing keys dot intersect of required. Oh, good point, Coriolanus. Yes, if I had turned that iteration around. So Coriolanus says, if you don't need to explicitly construct an intersection. If when iterating over required keys, all keys are present, then you know that all keys are present. This also gets you short-circuiting behavior if you return early and false. This is very true. Thank you. And I am going to do exactly that. It's a very good point and saves a little hassle. So, for key in range of passport, we just say if not existing keys, if required keys dot contains key, if not required keys, then return false. And come on. And if we get all the way to the end, then return true. That's so much cleaner. Thank you very much for that. Yeah, that's exactly right. This doesn't need to be here. Left over from editing. What's happening here? Oh, needs validation. Okay. This validates part A. And all right, and now that we've got this, not this. Thank you, Go. Go has a nice, still inverted. You need to range the outer loop on required keys, not P. For key and range required keys, you're right. If P, and so actually dot, wait, if not star P dot, what's going on? Oh no, there is no star P. Sorry, P. Oh, I need to cast it as a map. Wait. Passport. Oh, because I made a type. Oh, of course. I've forgotten how to do this in Go, that's all. I use too many programming languages. Sorry. All right. I'm going to... So, the way you do this in Go is you say P square bracket key is your indexing operator, and I don't care about the value in this case. Underscore OK colon equals P of key semicolon if not okay. In other words, if the required, so we're ranging over the required keys, and if the required key is not in the passport, then we are done. We can return false. So this is saying look up the value of P of key, return okay if it's found. If it wasn't found, return false. If we go through this whole thing and all of them are found, then we return true. And that is a lot happier. So now that I can use validation here, I'm going to go through the range of passports. I'm going to validate each of them. So we're going to have a counter. So valid count is 0. And we're going to say if valid count sorry, I have a new keyboard and I haven't figured out where my plus key is yet. Now we're going to return valid count. No semicolons in this language. So format.printdef for valid in part A. Okay, so that's that. And we need a new line. And we're going to do this with the sample data, and the answer we should get was defined by here. It says should report 2 valid passports for the sample data. Testing return at end of function. Line 19. What did I do? Oh, here we go.
Doing great.
Wait, did I end up using this? I did not end up using the return value, so I am going to actually remove the return value because that's unnecessarily. It's an unnecessary feature. So now it looks like I have no errors in the source, obviously. But I'm assigning to an entry in a nil map because I constructed a map without using make. And I did that. Construct a passport. Wait. Parse from expects me to pass it expects me to have a passport. So we do a new passport. Oh, it's a make passport. Shoot. And in that case, then, since make is an actual object, I'm going to go ampersand. Wait. Allocates and I initialize. Make is the type of object. So I can't do that. Shows you I haven't been programming Go for a year. I don't remember how to do this. Passport is an actual object. Well, I guess I can do parentheses ampersand passport. Wait, does this work even if I don't? Because Go is smart enough to do this? I think maybe Go is smart enough to do this. Yes, okay. I forgot about that. Go is smart enough to realize that if you needed a reference to the object and it's not ambiguous to do so, then it can actually convert this to a pointer to passport and call parse from properly. So great, that worked. Now we're going to try it on the actual input instead of the input sample. So run it again. It says 204 were valid. Let's see if we're correct. Oh, interesting. Sorry, I'm going to fix this. Nope, that's not fixing it. Come on. $204. Submit. That is the right answer. Yay, we did it right. Okay, that was a little longer than it should have been, but that's okay. Now, the line is moving more quickly now, but they need some validation, but we have to add more validation. So we have a set of validation rules. Oh, and they have a different set of sample. Oh, they have sample data for valid or invalid. So this is actually a test in how well we're gonna this is by far the easiest way to solve this is with a set of validation rules according to the required keys. So that's interesting. We made a string set. But really what we want is for every one of these items in the required keys, we want to have a set of validation rules. And the easiest way to do that would be to have them have compiled regular expression patterns, because each of these, okay, so birth year is 4 digits. Oh, and there's also a number check, a value check. So it's not just... So we're actually going to want to associate a validation function with each of these keys. and then we're going to kind of call it for each of the keys. In our new world, required keys is now a map. Instead of being an array of string, or instead of being a map of string to nothing, let's rename that string set to validators, and the validators will be a map of string to validation functions, and then we'll fill in that map as we construct it. So my add function is going to have to change, but it's probably worth it. Okay, now then the second half of this is, can we do this in one source file, or are we going to have to do this twice? Now let's so here's what I'm going to do. First thing I'm going to do, I'm going to check this in. I'm going to check in the set of files I have right now, and just so I have a stamp of where we are. Go sum and go mod don't matter really, but and then I don't have to check in the Python file. So solve day 4 part A in Go. And just in case anybody wants to play with it, I'm going to push it. Okay, so it's up there on GitHub if you care. Meanwhile, let's now go back to this, and I'm going to do a couple of things here. I have a little type called string set. I'm going to create a new file. Set.go. And one of the nice things about Go is it makes refactoring so easy. I'm just going to carve off this chunk of stuff. And I'm going to put it in string set.go. Package main, and then paste this in there and save it. Oh, it doesn't even use any libraries. That's cool. Doesn't even need to import anything. And then main now doesn't have that stuff in there. We're just going to test it to make sure that it actually still runs. Go run main.go, and we'll just do string set.go. We could do this with build, but it's easy to just specify everything, and it still gives us the right answer. So we didn't break anything. Now we are going to make a validation. Whoops, that's the Python file. I don't care about the Python file. Sorry. The Go file. Now we're going to make a validation function. Validator. Not a function, a validation type. And this is for part B validation. So again, it's package main. And then we're going to say type validation part B is a map of string to a function that takes no parameters we're going to pass the value. We're going to pass it a string. And we're going to write the different types of validation functions that it takes a function string and returns a bool. So those are validators. It might actually be easier to think about if we do type validator as a function of string returning bool. Oops. Yeah, there's my F. Okay. I think Go is sensible with that. So, now, validation part B. We're going to construct one of these. All right. Let's write a couple of validator functions first. So I'm going to do a func year validator I'm going to curry this. So what this is going to do is going to return a validator. And so it's going to return a function that binds these years. And I'm going to return func of nothing, which just... Wait, what happened here? Func of nothing that returns a bool. Function of string that returns bool, sorry. So, so it's going to take S and it's going to parse it. So we're going to say if conv.a2i, no, you can't do that because strconv.a2i returns an error. So value error, let's call it year since this is a year. Year error is strconv.a2i of s, and we're going to get an int back, or we're going to get an error back. And so this then, and then if error is not equal to nil, so we get an error back, so then we're just going to return false. It's not valid. I don't really care what the error is. I just know that if we get an error, it's bad. And then if, no, we're just going to return year is greater than or equal to min, and year is less than or equal to max. So what this function is going to do is return a function that returns whether the year is within our min and max. And so when we call this function, we give it a min and max. And so this lets us initialize birth year, issue year, expiration year with just different ranges. So that's a quick way to get multiple validation functions there. And now we also need, so we can build a height validation builder. it does height in centimeters. No, we don't need a builder for that. All right. Func height validator is takes as a string, returns a bool. And this is going to extract a if s dot n string dot strings dot wait, where's ends with? Well, I'm confused. I just don't remember how this works. There's an ends with function. Isn't there? Has suffix. Strings dot has suffix. Okay, sorry. Strings. I'm gonna have to do the same parsing. You know what? I'm gonna do this with a regular expression again. Pat colon equals no. All right, so we're regexp dot must compile of it's going to look like a number, so 0 through 9. Okay, it's got some number of digits. And it could be 2 or 3 digits. If it doesn't match 2 or 3 digits, then it's not even, well, we know it's false. So we're going to go 2 to 3 digits. And then followed by either, all right, we're going to make that a group. Sorry. There's a group. And then that is followed by either IN or CM. All right, so that's my regular expression pattern. And M is string pat dot find string. I don't need all. I just need I need one. Find string submatch because I want those submatches. Find string submatch of S. And oops. Is that correct? Yes. It just takes and it returns an array of string. So M is now an array of string. If M is null. Nil. Too many languages. If M is nil, then return false. Otherwise, value error is actually, it can't error because I know that if this matched, that it's either 2 or 3 digits. So I'm going to ignore the error here and just put in strcom.a to I of m of 1, because again, that returned the whole match and then the 2 elements. So the first part is the value, and the unit is, I'm just doing this for convenience sake, m of 2, to just make the code clearer. So now I can switch on unit and case inch return value is greater than or equal to 59 and value is less than or equal to 76. Case CM um, 150 193 fault false. Actually, I can leave off the well, you know, it's fine. Go is smart enough to know if you've handled every possible case. So, I don't think I need these to be public. So I'm just going to do this. I mean, I definitely don't need them to be public. I could do everything lowercase, but I do like to think about what would be the public API of things. So, all right, there's my height validator and func. What's my other one? Eye color. Eye validator. And this is a simple pattern match, so I'm just going to do so this one is just one of several values. So A and B. Stupid. Let's just do this. Copy. Paste this. But I have to replace the spaces with vertical bars. So we're doing that, and m if pat dot, we don't even do an if, return pat dot match. If it matches, then it's one of those things. If it doesn't match, it's not one. So that's it. Okay, eye validator was easy. I'm missing a right. Oh, I'm missing a right. A close brace. Oh, I just stuck this in the wrong place. There. All right. Oh, wait. Match string. Passport ID is similar thing. In this case, we're going to match a pattern again, but in this case, it's just going to be bracket, colon, digit, colon, bracket, and there are going to be 9 of them. Thank you, regular expressions. That one's done. Oh, thank you, Golent. If you're going to spell ID, they want you to capitalize it. I don't disagree with that rule personally. And then country ID, ignored, missing, or not. So we still don't even bother to create a reference for country ID. I mean, they're there, but we can just ignore it. All right, so now that I have these validator builders, now I have to construct a validator object, which is the validation part B, and I have to fill it in. But we're going to do that in main. In the same way we did this required keys thing, we're going to create a function day4b. And, whoops, oh no. day4b takes a set of passports, and it builds a validation part B. So we're going to make one of those, and then we're going to say so we're going to just do these as regular indices. But we can still save ourselves a little bit of grief by doing this. Paste that. And then we say validators of that equals, whoop. Actually, that's fine. And yes, F doesn't exist, but so your validator builder. So we're going to do these first 3. Become your validator builder, and they each get different numbers. So this is 1920, 2002, 2010, 2020, 2020, 2030. Height is just height validator, I validator, passport validator, passport ID validator. So height validator. Oh, that needs a reference. We're not calling the function, we're assigning the function, and then later on we will call it. So height validator. Oh wait, did I forget hair validator? Oh no. Oh yes, I did. Okay, I need a hair validator. Yes, it doesn't exist. I validator and passport ID validator. Now I have to go back and write hair validator. So let's do that. Hair validator is just hexadecimal. Pattern match. So in this one, I'm going to just use a straight up, I don't think this has, does it have hex? X digit. Except that it's got uppercase in X digit and this says lowercase, so we're just going to give it the lowercase version. So we're just going to make our own. Pound followed by 0 through 9, A through F, 6 characters. Okay, that's my here validator. This constructs all my validators, and I probably... Oh, idiot. There. Okay. So now I have all my validators. Yay! And I need to... go through the range of passports, make a passport, parse from, and instead of calling passport.validation A, we are going to oh yeah, no, we can just write passport.validation B. That would make sense. So let's do this. And it's going to return valid or not. So now here's passport validation A and passport validation B. Instead of taking required keys, it's going to take a validation part B. So now we're iterating over the range of validators and we're getting a key, and we're going to use that to look up the passport value, and then we have the function and we're going to call the function. So first thing we do is we say if value okay. If we're not okay, we got to return false. Because we looked to required validator and it didn't exist, so we're still returning false. But if we got the value back, now we have to actually check that value. So if f of value, no, I just return if not f of value. So if f of value returns false, then we're going to return false as well. I did it again. Wait. Oh, that's inside the... Alright, so this is a goism. Very often you do this. You write the thing first and you need the value inside the conditional because this value is only scoped to this range. So I have to pull it out, put it on a line by itself, and then when you save, the semicolon will go away. So now we can check that value and we're good. So validation, so this doesn't want to be a validation A, this wants to be validation B. And day 4B is calling validation B, and it's not passing required keys, it's passing validators. And what I'm going to do is I'm going to take this list of invalid passports here and put it in a new sample file. So we're going to create a new file. Paste that in, remove this line of noise, save this, and we should have 1, 2, 3, 4 invalid, 1, 2, 3, 4 valid. So save that. And then we can go back to main and let's do part B. And we're going to do, okay, validation part B. No, sorry. Input sample B. Oh, not going to like me if I don't include validation.go in there. 8 were valid in part A according to our rules for part A, 4 were valid in part B. So it said that was right. So I think we ought to try it with input and see what happens. $180 were valid in part B. 204 are still valid in part A. That sounds right. 180 is a plausible number. I don't have any reason to think that I got it wrong. So I'm just going to try it. And if we get it wrong, well, we'll have to go back and actually do some debugging. It's not the right answer. We're too high. Shoot. Okay. Now we have to be a little more detailed about it. I am going to be right back. Need a quick break. So, excuse me for a moment. And don't go away. I will be 2 minutes. And I am back. Okay, hi. I was getting a little scratchy and told making some funny noises, so I'm trying to see if I can minimize that. Meanwhile, I got a beer, and so I'll make this work, and I should be done in a couple of minutes once I figure out what I'm doing wrong. So now we need to sort of debug why we're valid or not valid. We are saying that too many are valid. So some things that were not valid, some things that are actually not valid, we were saying were valid. So one question, continue to ignore the CID field, but each other field has strict rules. So I guess one of the possibilities are, so I did not validate that we only got 4 digits for each of these. Let's take a quick look at the data to see if there's possibly any places where we had the value was in range, but the number of digits was wrong. So in other words, 0, 1920 or something like that. So I'm going to look at the input file, and I'm not seeing... Oh, hey, here's a cool way to do this. Let's search using our editor, and we'll turn on regular expressions since we're writing regular expressions anyway. And we're going to say bracket, all the years end in YR, so we can do YR colon bracket 0 through 9 bracket curly brace. No, actually I'm just going to go star and see if there's any that look like they're 5 digits or otherwise invalid. I'm not seeing anything. So that part's okay, I think. Let's read the rules again. So the validation rules for year are for year 4 digits, at least 1920 and at most 2002. Did I do that right? What of my sample years did I do? Main.go 1920 2002, 2010 and at most 2020, 2020 and at most 2030. So then the validation routine does at least minimum and at most maximum. So that one seems okay to me. Height is a number followed by either centimeters or inches. And height matches 2 or 3 digits. Oh. You know what? Probably need a start of string here. In other words, this should match the entire string. And so we put a caret at the beginning, meaning the beginning of string, and a dollar sign at the end, meaning the end of string. And the same thing here. We need a caret here. And a dollar here. And a caret. Paren here. And a paren dollar there. And a caret. Caret. Number digits, 9 digits, and a dollar sign there. Let's see if that changes our results any. 179. So one of those things caught one more case that wasn't correct. That is, so in other words, if there were too many digits in a PID, for example, there were 10 digits instead of 9, then that would have still matched the way I had it before, but now it won't. So I'm gonna run the risk of entering the answer again, even though it makes me wait longer for doing it wrong the next time. Oh, what the hell? Let's do it. Yes, we got it. So, cool. Yeah, so that was a little longer, a little more detailed than I thought it was going to be. But, got it right. Tonight it's getting late, and so I'm going to let this end. I'm not going to do the Python version tonight. It would be more tedious work. There are some things that would actually be, simpler to pull off in Python, or I could cut some of the corners I didn't bother to cut and go to do a really fast version. But, part of the point of this stream is to show people, like, some things you might do in real life. So, that's my shot. And anyway, I'm gonna call it a night. I will, before I do that, let's commit this. So I'm going to add validation.go, stringset.go, main.go, my second sample data. Add that and push that up. So I will. Oh, thank you. Coriolanus says that I was faster figuring out the lack of string boundaries than he was when he did part 2. I'm saying he here because I happen to know him, so thanks for following. Anyway, thank you very much for coming. I'm going to try to do this every night for the Advent calendar thing and see how that goes. If I miss a day because something else is going on, I will try to catch up the following day. If these go long because some of these start, getting harder and harder, well, we'll have to see how that goes. But anyway, today was more tedious than hard. It wasn't too bad, though. It was kind of fun to do. So, thank you very much for coming and for watching, and I'll see you on the bit streams, so to speak. Take care. Good night.